Alright, hello everyone. So we just talked about cardioids, and those were a polar graph that had the same a values to a plus a separated by a plus or a minus sign. And now we're going to look at a new type of polar graph called the Limacon, and it's very similar, but there's one key difference. And the idea also is help look at this word Limacon. It kind of looks like lima bean, kind of the spelling a little bit. And that's important because a lima bean, it kind of has the same shape of it, so we'll kind of look more into that. But let's notice that there is a distinct difference now between this limacon and the cardioids that we looked before. Ooh, got wild on the highlighter. So here, our A and B are not the same. Okay, so A is greater than B in this case. So our first number has to be greater than the second number in order for this to be a limacon, unlike the cardioids we saw before. So let's go ahead, let's start graphing this to kind of see what the shape is. So I'm in polar. Remember, if you were not in there, go to mode, click down to polar, make sure you're in radian degrees. Also, I didn't mention this before, you could also use Desmos if you don't have your graphing calculator with you. Um, but one of those two options you're really going to use for the remainder of this chapter. And if you're having problems with it, reach out to your teacher as soon as possible so we can help minimize this problem and help you actually work. Because if you can't work or use your calculator, you're going to be kind of confused and it's going to be a lot harder. So let's go ahead and start plugging these equations. R equals 5 plus 4 cosine theta. Zoom 6. And here is my graph. So take that screenshot. I'm sorry, everybody. So remember, limacon, the main big difference is that A and the B are different. The A is larger than the B. And so if we were looking at the cardioid, it would come up here and come more down, and it came to this pole as a sharp point and bounced back. So instead of having a sharp point there, it actually is a little rounded off. So this one is pretty long out, so you don't see the lima bean or the bean action, but I think we'll see it in a little bit. So this is more of a rounded edge here than very much pointed and coming off. So we can still do the same thing where we kind of find the max. So I could plug into my calculator. I'm also just going to point here. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, when I'm in the x direction, I'm at 9, or it's not the x direction, sorry, when I'm in theta, and when I'm in the pi direction, I get a value of 1. So that is that. So let's go ahead and let's look at a couple more examples. I'm going to do this one right now. So 5 plus 3 cosine theta. Graph that. And I'm going to zoom in a little bit if I can. I'm going to make my window a little bit smaller. So here's a little better shape. We can kind of see how it kind of bounces in and out, and it's not a sharp point anymore. And again, we're going to do all three at the same time, and then kind of look back at them and see what we might notice. So 4 minus 3 sine theta. Let's do the regular window. And the last one. Feel free also, if I'm going too fast, you can also pause the video. Make sure you get these in your calculator and they look the same. I don't want you just to copy it down because a big part of this is that you're actually able to graph it, and we are allowing you the capabilities of using your calculator on your test. So we want to make sure that you know how to use this as best as you can. I still can't see that little divot as best as possible, so I'm going to adjust it a little bit more. Now that just looks like a circle. Going back to Zen 6. That's kind of the best we're going to get right now. I don't want to take too much of our time just trying to fuddle with this graph. Alright, so let's see what other things do we notice here. So if we think back to the cardioids, again we see when we have this cosine, the graph is definitely wider along this axis. It's more horizontal than vertical. And when we do have a sine, we see it is now up and down. That point is in what we normally think of as the y-axis, while the point here is more on the x-axis. So cosine, horizontal, sine, vertical. Also, if it's positive, the end of it, or like the stretched out part, comes out in the positive direction. So think of our theta. This is 0. We're in the positive. And here now we're negative, so it's in the what we normally think of as the negative direction. And same thing now here, if its sine is negative, I expect the long sine to be pulled down in the negative direction as well. If I go ahead and just show one really quickly, if I switch this out to 4 plus sine, let's graph this, we can see that it's pulled much higher in the positive direction. So you can see, and if we picked out some points here, we have 1, 2, 3, 4, 5, 6, 7, 8. So I get this point to be 8. This point is 2. Let's see, what's this? 1, 2, 3, 4, 5. So maybe you can start to see some patterns here. Let's do one more and then we'll kind of talk about it. Maybe you can start to see something. So 1, 2, 3, 4. 1, 2, 3, 4. Yeah, 1. And 1, 2, 3, 4, 5, 6, 7. So, do you see any patterns in this arising? One might be these. We see this 5 in our equation. We have our 5. So, the direction or the point that's not in the max and minimum. So if we think about this maximum, we have this 8 all the way out here because this is a cosine, it's horizontal. So when we go in the other direction, we go in that what is the vertical direction. We go up 5, which is our A value. Here, sine is normally vertical, so the opposite direction would be the horizontal for it, and it also has the A value, 1, 2, 3, 4, and 4. So the A kind of gives us the value of the graph on the axes of the opposite direction. And then we ask, oh, how do we get 8? Well, we have 5 plus 3, 8, and then 5 minus 3 to get our 2. Let's see if that still holds. 4 plus 3, yeah, that's 7. 4 minus 3, that's 1. So that also holds. So to get these other points in the direction of that it normally is, so if it's horizontal or vertical, you can add and subtract A and B to get your points. And kind of think about it. If I'm positive, I'm stretched in the positive direction. If I'm negative, I'm stretched in the negative direction of which it would be. So we kind of put it all together here on this graph. So remember, it's a lima bean. It kind of has this shape of a bean. It doesn't come and bounce hard and make a hard cusp. Instead, it is more rounded off. The A has to be bigger than the B. That's the big difference versus the cardioids we saw earlier. Limacon, the A is bigger than the B. And if you see, we get our points as A plus B, A minus B, and then it's just 0, A, 0, A. Here, if we're in sine now, it's A plus B in the vertical direction because sine is vertical, A minus B in the other direction, and now the opposite, now it's the horizontal, is the A value. So, some patterns to see in the Limacon. You're going to look at another version of a Limacon in the coming days, so be prepared for that. But again, we just want you to be able to look at these graphs or look at the equations, make sure you can use your calculator, okay, set your window, and kind of identify the graph and maybe pick out some key points.